Hello everyone, I hope you all are good and you all are practicing problems. Let us for now do this question. So what is said in here, there is one L-shaped structure and this rod has both its sides of length L and mass of each side is given as M. So geometrically and mass wise they are identical. The rod is placed on a smooth horizontal surface with its side AB horizontal and BC is vertical. So AB portion of this rod is on this horizontal plane which is smooth, so there is no friction over here, and BC portion is vertical. Okay, so if you tell that this is the direction of y-axis and this is the direction of x-axis, then this will be the direction of z-axis. Okay, which is parallel to your BC. It tumbles down from this unstable position and falls on the surface. Why this is an unstable position? Because you can see it is not, it is not fixed at the base, and then there is this uh, center of mass of this BC portion lying in this vertical plane. So because of gravity, it will have tendency to fall down. So it is unstable. Find the speed with which end C of the rod hits the surface. So it is getting asked that when this rod will hit the surface, what will be the velocity of, let's say this is end C of the rod. Okay, so how we can, talk about this question. First of all, we must realize here one thing that this surface is smooth. और अगर ये horizontal surface is smooth है, आप ध्यान से देखो, on this AB there won't be any force acting, right? There is gravitational force acting on it, but that will be in the minus z direction, mg, and then there is normal reaction acting here, and that will be in the plus z direction, and vertically it is not at all in motion because it is kept on the surface, so it is constrained to be on the surface. So n will be equal to mg. Other than n and mg, which is getting cancelled, there is no other forces acting on the AB, है ना, क्योंकि friction है नहीं. So if it will try to fall down, friction won't act in any way क्योंकि है ही नहीं. Done है. So friction is not there. It means there is no force acting on this horizontal plane, on this rod portion AB. And if there is no force acting, this AB will not translate. And if it is not translating, we can say that this AB will stay fixed in this space while BC will fall down. We can say that, right? So if BC is falling down, AB position is fixed, we can take axis of rotation uh, along the line AB, because you can see if this will fall down, there will be a thing of rotation, right? So we can talk about rotation axis along this line AB. Okay, so let us talk about that first. So if this we are taking as axis of rotation, and if it is falling down, this will be the case of pure rotation, right? Around line AB, we can say that the body is in pure rotation because for this body, that is rod, there is this portion of the rod which is fixed in the space. Not physically, हमने इसे fix नहीं किया है, but because there is no forces acting, it is fixed in the space. And you have read that when certain body, if you're given certain body and if it is fixed around certain point, then it will perform rotation around an axis passing through that point, and that rotation will be a case of pure rotation. Done है? So this is also a pure rotation. And if you write the initial energy of the system, initial energy क्या है? Zero, because there is no kinetic energy. Sorry, not zero, it will be initial energy. I'm talking about mechanical energy. We can conserve this mechanical energy. Why? Because there is no dissipative force acting, there is no friction, no air drag getting talked about. So yeah, we can conserve energy, right? So mechanical energy आप कैसे लिखते हो? Kinetic energy plus potential energy. और kinetic energy क्या होगा यहाँ पे? Half, initially it is zero, right? It is in rest. Potential energy, center of mass of AB portion is over here and BC portion is over here at a distance of L by 2. So what will be the potential energy, total mass of the system? और individually अगर आप लिखो तो mg into L/2. अगर total mass of system करते हो, center of mass निकालना पड़ेगा, which will be at a distance of L/4. Done है? So we are not going with that now. So mg into L/2. ठीक है, बिकॉज पोटेंशियल एनर्जी ऑफ ए बी पोर्सन इज जीरो, वी आर टेकिंग दिस एज द एच इक्वल टू जीरो बिकॉज दिस इज जेड इक्वल टू जीरो का लाइन डन है. सो फॉर ए बी इट इज जीरो, फॉर बी सी इट इज एम जी एल बाई टू. सो दिस इज द इनिशियल मैकेनिकल एनर्जी. what will be the final mechanical energy when this rod has fallen through that height to lie upon this horizontal surface? So इस केस में अगर आप देखो तो दोनों का ही center of mass is lying on this horizontal plane, that is in xy plane, right? So z coordinate is zero, potential energy is zero. So final mechanical energy अगर आप लिखते हो, that will make us write potential energy is zero and kinetic energy आप क्या लिखोगे, half I omega का square. Now what is this I? So I is the center of I is the moment of inertia of this rod around line AB. अब AB इस रॉड को आप दो पार्ट में ब्रेक कर लो. रॉड इज मेड ऑफ AB plus BC. What will be the moment of inertia of AB part around an axis passing through AB? It will be zero, right? Because our value is zero over here. And for BC, if you see, this is a rod and it is rotating about an axis passing through one of its end. So it will be equal to ml square by 3. ठीक है, सो दिस इज योर मोमेंट ऑफ इनर्शिया. अब आप यहाँ पे लिख डालो हाफ इंटू एम एल स्क्वायर by 3 into omega square, and this is going to be equal to mgl by 2. 2 will get cancelled, m you will write here, and omega square को आप क्या लिखोगे, you will be writing as 3g by l root under, this will be omega. Okay, so this is omega. Now what will be the speed of point C at the point it is hitting the ground? ठीक है, so C का आप क्या लिखोगे, I mean what will be the speed? So axis of rotation is this thing, and omega when it is hitting the ground, we have got this because this conservation thing we have written at the point when this rod, one point is when the rod was upright, done hai, and another is when the rod has hit the horizontal surface, right hai? So omega is the value of angular speed when this rod has hit the horizontal plane. So at that point of time you can see this is your axis of rotation, and distance of point C from the axis of rotation, perpendicular distance, is your L, right? It is L, right? So velocity we are getting asked, right? So find the speed, yes. So speed of C point will be equal to omega L. Omega is root under 3g by L into L, and this will give you root under 3gl. Okay, so this is going to be the answer. But but if you want, I mean this was the doubt question actually. So they want me to solve it for rotation around center of mass thing. So let me do that one. Now I mean safest position to talk about is to talk about रोटेशन अराउंड एन एक्सिस पासिंग थ्रू सेंटर ऑफ मास. जैसे आपने ये पढ़ा होगा कि इफ बॉडी इज हिंज तो कोई डाउट ही नहीं है, इट विल रोटेट अराउंड एन एक्सिस पासिंग थ्रू दिस हिंज पॉइंट. बट इफ बॉडी इज नॉट हिंज्ड, हियर आल्सो body is not hinged. Done it? Force condition was unique, that is making AB, I mean fixed in this space. But if this is also a free system, right? So if there is a free system, undoubtedly we talk about rotation around an axis passing through center of mass. क्योंकि center of mass वो position होता है जिसके around body का center of mass, sorry, moment of inertia minimum आता है. ठीक है, so it has tendency to rotate around center of mass easily, more easily than any other point. So we go with calculating or doing anything. Sorry, when we talk about rotation thing, when the body is not hinged, we talk about its rotation around an axis passing through its center of mass. So हमारे पास दो ही कंडीशन होता है, हिंज नहीं है तो सेंटर ऑफ मास के अराउंड जाएंगे, ब्लाइंडली वी कैन गो. अगर जैसे यहाँ पे हमने एनालाइज किया तो ए बी के क्रॉस जा सकते थे. सो अगर वो नहीं करना, यू कैन ब्लाइंडली राइट थिंग्स अराउंड सेंटर ऑफ मास. ठीक है, तो चलो सबसे पहले सेंटर ऑफ मास को लोकेट करते हैं. सेंटर ऑफ मास ऑफ रॉड ए बी इज ऑन द वाई एक्सिस, सो इट हैज अ कोऑर्डिनेट ऑफ 0, L by 2, 0. And this is on the Z axis. So this has a coordinate of 0, 0, L by 2. So if you calculate its center of mass, you will be getting the value of YCM. That will become L by 4. And you will be getting the value of ZCM. That will make it L by 4. So center of mass will be somewhere here in the YZ plane. And this is L by 4 and L by 4. Now what you do is you take this point and then talk about an axis, because तुम्हें भी पता है अगर ये rod ऐसा है, it will rotate around such axis. ठीक है, so let us talk about this axis. which is parallel to your what AB thing. Okay, this axis is parallel to line AB. So यहाँ से अगर आप इसको एक्सेस मानते हो, ठीक है, विच इज पासिंग टू सेंटर ऑफ मास, एंड देन वी हैव टू गो फॉर द कैलकुलेशन. तो चलो अब कैलकुलेशन की बात करते हैं. अगर आप लिखो यहाँ पे, वी आर टॉकिंग अबाउट सेंटर ऑफ मास, एंड सेंटर ऑफ मास व्हाइल दिस रॉड विल फॉल डाउन इज ऑल्सो मूविंग. डन है. Then under the effect of gravity, this will fall down. So this center of mass has a vertically downward motion, and then there is one axis passing through the center of mass around which this rod will rotate also. So this is a question of translation plus rotation. So this is not pure rotation. डन है. सो दिस इज ट्रांसलेशन प्लस रोटेशन. अब यहाँ पे इनिशियल एनर्जी अगर आप लिखना चाहते हो, इनिशियल मैकेनिकल एनर्जी, सो यू विल बी राइटिंग एज m2mg into center of mass का position from this ground, and this is equal to how much? L by 4. So this is L by 4, so this is mg L by 2, same as before, right? And final energy if you want to write, so final energy आप क्या लिखोगे? Finally there is no potential energy, right? When the rod will be in this position, there won't be any potential energy. Kinetic energy आप लिखोगे half I omega square plus half mv square. ठीक है, both the factor of translation and rotation. So if you have to talk about if you have to write this thing, first of all we need to calculate I, then we need to calculate relationship between velocity and omega. ठीक है. सो देखो वेलोसिटी और ओमेगा का रिलेशन हम निकाल सकते हैं. वी नो दैट ए बी इज फिक्स्ड इन दिस स्पेस, राइट? सो वॉट एवर इट्स वेलोसिटी इज बिकॉज ऑफ रोटेशन विल बी बिकॉज ऑफ ट्रांसलेशन, मेकिंग इट इक्वल टू जीरो. सो बिकॉज ऑफ रोटेशन at the time when rod is hitting the ground will be equal to omega distance of AB from the center of mass thing. So that is L by 4. So omega L by 4 will be equal to V. That is VCM, right? So this is V. This is the relation. Okay, and next thing is the calculation of moment of inertia. So moment of inertia of the portion AB अगर आप निकालते हो तो AB का क्या होगा बताओ? AB, this axis is parallel to this. First of all, let us talk about one axis over here. So this axis के through the moment of inertia AB का zero है, and then this axis is at a distance of L by 4. So moment of inertia around AB will be equal to 0 plus, by parallel axis theorem, 0 plus M L, uh, how much it will be? ML square ML by 4 का square. डन है. सो देखो यहाँ पे ए बी है. लेट मी टॉक अबाउट इट इन अदर डायग्राम. सो दिस इज ए बी, इट्स सेंटर ऑफ मास इज ओवर हियर एंड देर इज एन एक्सिस पासिंग थ्रू इट, and then there is one more axis which is parallel to this one. Done it? And between these two distance is L by 4. So this will become the line of ICM for AB, and this is another line which is parallel to this line. Okay, so you will be writing ICM plus M L by 4 ka square. ICM is 0, right? So moment of inertia around AB you will be writing as what? ML square by 16. Now moment of inertia of CB around this line, along this line will be how much? So this point is passing through L by 4 thing. So this is L by 4, and ये ऐसा practically दिख नहीं रहा, but ठीक है, यहाँ पे L by 2 ले लो आप. ठीक है, practically नहीं नजर आ रहा है ना. काफी ज्यादा ये वियर्ड लग रहा है. सो लेट मी ड्रॉ इट मोर क्लोजली टू द ए बी. सो इट इज दिस लाइन. ठीक है. अब देखो, इफ यू टॉक अबाउट दिस लाइन, this is the center of mass of the composite system, and this is the line along which this body is rotating. Center of mass of BC is around this at this point almost. So if you talk about calculating moment of inertia around an axis passing through its center of mass parallel to this line will be equal to how much? ML square by 12. ठीक है, because if there is a rod and if there is this center of mass, moment of inertia around this line is ml square by 12, and then distance with this is L by 4. So moment of inertia of IBC will be equal to ml square by 12 plus ml square by 16. So overall, if you calculate moment of inertia, you will be writing what? ml square by 16 plus ml square by 16, that will make it ml square by 8 plus ml square by 12. So do one thing, denominator को आप same कर लो. That is what I do often. So this is this. If you write it, it will become how much? This will become 5 ml square by 24, right? So this is the moment of inertia. Okay, this is the total moment of inertia. Done it? Yes. So this is this. Now let us put the values. So values अगर आप put करोगे mg l by 2 is equal to हाफ एम वी स्क्वायर. देखो यहाँ पे मैंने एक्सप्रेशन गलत लिखा है. हाफ एम वी स्क्वायर कर रही हूँ ना, 2m आइसो 2, बिकॉज वी आर टॉकिंग अबाउट काइनेटिक एनर्जी ऑफ द होल सिस्टम. सो हाफ 2m इंटू वी का स्क्वायर, ओमेगा चलो निकालते हैं. सो वी का रिलेशन क्या है, ओमेगा एल बाई 4. सो यू विल बी राइटिंग हियर ओमेगा एल बाई 4 का स्क्वायर प्लस हाफ आई ओमेगा स्क्वायर. आई क्या है तुम्हारा 5/24 एम एल स्क्वायर एंड देन ओमेगा का स्क्वायर. ठीक है. सो इट इज दिस वन. नाउ लेट अस सॉल्व इट. सो टू टू को आप कर लो कैंसिल. ठीक है. एंड देन व्हाट वी आर लेफ्ट विथ, एन को भी आप कैंसिल कर लो. डन है. सो वी आर लेफ्ट विथ हियर जी एल एंड दिस इज इक्वल टू हाउ मच, ओमेगा स्क्वायर एल स्क्वायर बाई 16, दैट विल मेक इट 8. ठीक है. एंड दिस इज हाउ मच, ओमेगा स्क्वायर 5 ओमेगा स्क्वायर एल स्क्वायर डिवाइडेड बाई 24. So this will again make it 3 and here 3. So this will become how much? This is your 8 omega square L square by 24 and this is your 3. So GL. अब यहाँ पे आप क्या लिखोगे, ओमेगा स्क्वेयर इज इक्वल टू 3g बाई एल. सो ओमेगा इज इक्वल टू हाउ मच, रूट अंडर 3g by L. This is omega, right? Now what will be the velocity of C point? So C point ये है and axis of rotation is where? It is somewhere here at this point. Sorry, this is the axis of rotation. So what will be the distance of this C thing from this point, this line? So if you, look at this distance, this is equal to how much? This whole is L and this is your how much? This is your, this was L by 4, right? This is L by 4 and this is L. So this is 3L by, L minus L by 4. So 3L by 4. Okay. So omega into 3L by 4. So if you write the velocity of center of mass at this point, because of rotation it will be, sorry, एक काम करो, velocity of c क्या लिखोगे, velocity of c because of rotation and because of translation. So because of translation it will be equal to v and because of rotation it is going to be omega into 3l by 4. ठीक है. सो v का वैल्यू ओमेगा के टर्म में क्या था, सबसे पहले आप वो लिख लो. v का वैल्यू ओमेगा l by 4 था, राइट? सो राइट हियर ओमेगा l by 4 plus 3 omega l by 4 and this will make it how much, 4 omega l by 4. So basically this is omega l and omega into l is how much, root under 3g into l. ठीक है. So this is the answer we are getting, same as what we got before from the first method. Okay. So I hope you have understood this question. Second method was more demanding in the case. We were dealing with two things, rotation plus translation. So definitely it was more complicated and previous one was more easy. And in this question, previous one was the case we could have taken. Okay. So I hope you have understood this question, but if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.